Hi, welcome to the webinar series of Analyze MyWorkpiece Toolpath. My name is Oliver and I'm the product manager for Analyze MyWorkpiece Toolpath. This is now the third webinar, and which is all about interacting with this menu and analyzing your point cloud using color coding and other functionalities. The preceding webinars were all about importing data and create point clouds, and also the second webinar was all about this menu, helping you to interact with vectorial data of your point cloud and also a little bit interacting with the appearance of the point cloud. And now this webinar will all be about that menu here. So again, as a precondition, you first should have imported data, and let's directly dive into this. So we have now here mold and die part, which, let's say, those of you who are a little bit deeper in the machine tools industry, probably you might know this test part. It is used to check the behavior of a machine tool and the performance. And we have now here data coming from a numeric operate trace, which is visible by this XML file format. And we now get started with this 4D tab. So basically you have here on the bottom a couple of tabs like 4D, points, measurements, selection, properties. If you have imported an MPF file, you even can see another tab which is called Gcode list, which I will show in a few minutes. And if you have data coming from Analyze MyWorkpiece Capture or Capture for Analysis, you can see even more tabs. But independent from the imported data, what you always see is this 4D tab. And now let's dive into it, because this is a very important one. So basically what you can do by it, you visualize scalar data on your point cloud. So whenever there is scalar data available, so basically just data points that are mapped to the points in the point cloud, you can visualize them. So let's start with a typical example. Let's visualize the velocity of the tool center point alongside the tool path. So first of all, if you click at it, that's the calculated velocity, so the velocity that Toolpath automatically calculated. Toolpath creates now this kind of color coding, and what does it tell us now? It looks very bluish. There are a few red areas, but the rest of it is quite blue. And what does it tell us now? Toolpath now analyze what is the minimum traveled speed of the tool center point and the maximum. And the maximum goes up to 64,000 millimeters per minute, so 64 meters per minute. And yeah, it's quite obvious that these are areas where a G0 code was active, so fast traveling. And what you as a user normally would like to do is you want to check whether the programmed feed rate was reached. So since I now know that the program feed rate for this program was 10 meters per minute, let's type in 10,000, as Toolpath always operates in millimeters. And now we see something like that. We see gray areas, red areas, and blue areas, and everything in between. And now we see, okay, this color palette ranges now from 0 meter per minute to 10 meter per minute. Simply by clicking into this field and changing the value. What I could have also done is, so let's restore the original limits. I could have taken the slider here and changed it to a value. This could be the case if I don't know what was the program feed rate. Then we could simply try to find it out and say, okay, once bigger parts of the workpiece become gray, then we see, right, okay, this is probably this is probably the border, and we see, okay, it's somewhere around 10,000. Yeah, so let's type in 10,000 for now, and again those gray parts come up. And what do the gray parts mean? Gray is everything which is outside of these given range adjustments. And if we don't want this to be gray, we now have two possibilities. Either we increase the value here, like as an example, to 11,000, and then we don't see gray parts anymore. Or let's take a smaller number. We could take like 10,050. What is also possible, if we would closely stick to the 10,000 and still don't want to see the gray areas, we can uncheck this mark here, show values outside scope gray. So by doing so, everything which is now outside of the limits is also now colored in red or in blue. But keep in mind, red does not necessarily mean 10,000 millimeters per minute. It could also mean that it's more. In case you want to clear the coding completely, you can click this button. And before doing that, let's just come to the last checkbox saying swap color. So now blue and red and everything in between has been changed. Now blue are the fast areas in my workpiece, and red is where the tool travels slowly. And if we want to clear that, let's just click clear 4D coloring, and we are back in the original scene appearance. And we are not only restricted to visualize the velocity, we could also check the acceleration alongside the tool path. So to see areas where the tool is accelerating more quickly or not. And we see that the acceleration looks quite homogeneous. Not so many changes, and also it works for jerk. So these are the three values that are always calculated by Toolpath. Then we have the curvature. You have also already learned in the last webinar what the curvature means. So we can visualize the curvature as a vector, as you remember. So if we do a sub-selection here, the curvature is now only visualized in the selection. And for now, let's just take this area here, click the I button. Now the scene is only showing the curvature vector here. And for a second, let's make the curvature invisible. And now we have a 4D coloring for the curvature, red areas, and it's based on the magnitude. So blue means 0 magnitude of the curvature or close to 0, and red in this case, that's the limit I just set, is where the magnitude of the curvature is higher. And if we now visualize the curvature, we see, okay, yeah, the vectors are in the colored areas longer than in the in the blue colored area. And sometimes you might want to know whether there are quickly changing curvature areas, because this then always or also could indicate an area where you have speed drops in your real process. So let's check whether there is a connection, and we see directly there seems to be a connection. Yeah, for sure the tool, the machine tool has to slow down here in order to machine this fine radius. Here the radius is much higher, so the tool can travel quicker. So this is now a color coding for the velocity. Blue means slow, and we can see that the tool is really slowing down here. And taking the curvature, we see at least also the magnitude is increasing. So the higher the magnitude, the narrower the curve is. And if we also now take the vectors here and yeah, look at it, we see that in this area it's really increasing. I mean, makes sense. We also see it from the point cloud. Oops, that was a little bit too much. Okay, let's go back to the whole workpiece. So 4D, what else can I see here? Let's get another example. You are not only restricted to the signals that are offered here, you can also use the color coding for self-defined signals. So first of all, let's close the scene and let's import another example. And I suggest to take this one here because it contains lots of data. So first of all, we do a position mapping against the commanded axis position. That's, as you know, what you should do at least when importing process data. If you don't know that, then I suggest to go back to the first webinar, which is all about importing data. And let's now try to take the torque values and make them a vectorial property of the point cloud. What that means you can learn in the second webinar, which is all about visualizing vectorial data. So I selected the torque here and gave it the XYZ component, and I want one signal also to import just to show you how you can visualize custom 4D coloring. So let's take the commanded speed, and for some reason let's take the torque. Let's take the spindle torque. Also very important value. Let's just write spindle torque. And now what I select here is scalar. Since the spindle torque for me right now here, it doesn't have a room direction. It's neither X, Y, Z. So it's simply just a scalar value. Let's import that. So this is our point cloud, and currently not colored yet. And let's now move to one of those drilling holes. And let's see what we can get here. So if I now uncollapse this combo box, besides the velocity, acceleration, jerk, and curvature, we now see two new entries. One is the spindle torque. So we can visualize the spindle torque now also color coded. And as I just informed you, Toolpath now takes the maximum limits first as a standard value. So if we want to learn what is going on here, we first of all should narrow down the borders, and we now can see, okay, this is going, okay, now with the gray values come in. So that's what I just do. I try to create a limitation that makes sense for this area. So let's set it to 1.45 and to probably 0. It can be even a little bit more, 0.25. Let's make the points a little bit bigger again. So this is now the spindle torque in this area. So a completely self-defined signal. And what I can also visualize in this area is the torque of the motors. So I imported torque for X1, Y1, C1, and we now see it looks a little bit different here, this 4D coloring tab. If I select spindle torque, I see scalar. And if I select torque, it tells me, Toolpath tells me XYZ. And XYZ in this case means, okay, Toolpath understood this is a vectorial data set, and as you remember, we can also visualize this custom vector here. And now we see color-coded the magnitude of this vector. And let's just again create a range that helps us a little bit to understand what is going on. So I shrink the range until we start to see gray dots. both directions, something like that. And if I'm now, what we now see is the magnitude of the torque vector. And if we start to click here on the components, now only Y and C is marked. That means we now see the torque vector only for the Y and C component. And if we reduce one more component like this, now only the C component is selected. So we should have selected at least one component. If we don't select anything, everything becomes blue. So let's just select the C component. What we now see is the color coding of the torque of the C1 axis. So this is now again a scalar field that we are seeing. And if we take two components, we see the magnitude of the vector of the torque in YC direction. And as an example, if we click it like that, then we see the magnitude of the torque vector in the XC direction. And if we just have this component active as a repetition to get a better understanding, because this sounds a little bit complex at the beginning, this is now the torque of the X1 motor color coded. So again, if we want to see what is happening here, let's narrow it down until first points become gray, and then we can see what is going on here. Now what do we see here? We see that the X1 motor, as an example, is doesn't have any torque, or not a lot of torque, let's say, when the drilling tool enters the hole, but at the very end the torque increases to like 6.3 Newton meters roundabout. So this is the 4D coloring tab, and I can only encourage you to play with it around and learn a little bit what is going on there, because there is a lot of information you can drag out of it and yeah, let's say answer many process related questions. Okay, so much for that. Let's come to the next tab, the points tab. Yeah, first of all, we have this button here. I always like to click it because what is basically doing it, it pushes the menu to here, and then we can see a little bit better what is going on here in the table. So here we see basically all the data that has been imported and calculated by Toolpath. So we now see torque, spindle torque, curvature, velocity, and so on. And yeah, we basically see, due to all those zeros at the beginning, it took quite a while until the traveling of the tool really began, somewhere around here. And let's say, okay, assuming, what can we do now here besides watching our data? First of all, we can, let's say if I want to find out what is going on here, I can select this area, and now I want to see the data here on the screen. How do I do that? I click this I button. It looks very similar to that one here, but it's a little bit different. It now says show only selected points, but here in this table. So we see this tabular data now, and it's now only reflecting the situation that we have here. So if there is a special location in your workpiece and you want to better understand what is going on there, make a sub-selection of the points, then click this button, and then you only see this information here bound to that selected points. It also goes vice versa, so assuming you have, let's say, selected these points here, so you can make selections here in this table also, and also unselect parts of it. And if we now want to see where in the workpiece this is, we can say fit to selection. And now we are here. So that's okay. That's the tool changing. Yeah, the place where the tool changes take place. And this is where Toolpath now brought me. So wherever you do your selection and you click this button, then Toolpath will bring you there. Let's just try it again. Here we are now. So this is, yeah, this is here in one of the holes. And we can also undo it. So there is always this undo fit to selection in this case. So whenever, in case you did an error, then you can undo it. Then we have in the points menu also this eye, show point information. So let's say, assuming we have the selection here and we want to see, okay, where is this actually? Of course, we can, click here and then we see, all right, this is the point with the index 130,194. So that means I could do now a right click and type in the value, but what was it again? I forgot what to do. You can click here the eye, click on index, and now you see the index of this point in the point cloud. So this is always resizing, doesn't matter how much you are zoomed in. And now I can make a right click into this table and say, please scroll to 133,194, and now this is the point we have selected here. And if we select further points, we see the index here and also more selected points here. For instance, if we don't want to see the index, but let's say the coordinates of that point, this can also be done clicking here on eye and coordinate. We can also, add information like show me the index and the coordinate. We can visualize the velocity of the tool center point, same as the velocity in this 4D tab. Show me the curvature, the magnitude, and if the dataset contains it, you can also see the Gcode or the NC code that is active here. This is not always possible. It works if you have imported an MPF file or data coming from Analyze MyWorkpiece capture or capture for analysis. With trace data from Cinematic Operate Trace, unfortunately, you cannot see the Gcode here. So this is the points tab, and now let's come to the measurement tab. And for that, I suggest let's first change the example. So we will now import this MPF file here and into the same scene the corresponding process data. And just for the sake of the beauty, let's just also import the STL file. So from the preceding webinar, you probably remember this geometry, and let's just use this to execute some measurements. Okay, for a minute I will make the STL file invisible. So here we are, measurements. You can execute measurements on all these points here. It doesn't matter whether the points are of the same model or not. And let's assume you have the following use case. You want to find out what's the distance between the commanded position here, or the actual position value coming from the MPF file, and the one that the CNC made out of it. So first of all, that we better can distinguish the two lines, let's click here on the MPF, on this color palette icon. Let's change selected unselected points to red and the line to yellow. Now we see, make it a little bit bigger. Now we see the blue line and the green dots are the CSV file from Operate Trace. So let's process data, and the yellow line with the red dot, that's the programmed path. And now I want to see what is the distance, the maximum distance between these two. And therefore we have several measuring tools. So you first go from the 4D tab to the measurements tab. And you can now, as an example, measure the distance between a line and a point. So first, let's make a line. And Toolpath always tells you what you need to do. So it says here, select exactly 3 points. So let's select exactly 3 points. The first 2 points will create the line. And the third point is then the point from which the line's distance will be calculated. And now you see 2 new things here. A green line, that's an auxiliary line that you've just created, or I just created with those 2 points. And then this yellow one here. This yellow line, oops, let's just change the center of rotation by double clicking on one of those 2 points. You now see this line has been created. And the result of that line is written down here. So the distance between those 2 points from our toolpath and the MPF interpolation point is 0.1447 millimeters. It's here in the results column. We can even expand it to this area if we want to have it in a, let's say, more prominent pane. And we can also see it here, and we also see the result for all the 3 components in X, Y, and Z direction. And type is referring to the kind of measurement that was executed. So we see here distance between a line and a point is type 3, distance between 2 points is 1, and so on. So for now, let's undo our point selection. This time I take this here. And now the measurement is gone, but we have a history. So if I click on the history again, we can see the measurement we just did again. So let's take another type. This is called distance between 2 points. It tells me now select exactly 2 points. So let's click this one here and this one here. And now we have the distance between those 2 points. And again, we have the result here showing the absolute length in millimeters and then all the 3 components in X, Y, and Z direction. And now it tells me this is type 1, so it's distance between 2 points. And if we hover over with the mouse here on the type, we see again what type it was. We can even show this information here on the scene. So if you want to create a screenshot and we want to discuss as an example with a colleague, okay, is this a distance between the actual toolpath and the programmed one okay or acceptable? We can check here, show measurement information on scene. We click the camera icon. Let's add some date and hour, and now we're good to go and save this. And yeah, just for the sake of completeness, let's create a new measurement, calculating the distance between a plane and a point. There could be a use case where you need that. So Toolpath tells me select exactly 4 points. So let's create a plane first. Just find a nice example. Yeah, something like that. So the first 3 points I'm clicking will create a plane. And then the next point we are clicking. Okay, this is maybe not so good. Let's take it from here. 1, 2, 3. And the 4th point we select is the point from which the distance is calculated. So what did Toolpath now do? Let's just rotate a little bit more helpful. So this green one is now the plane that was created by Toolpath, selecting the 3 points. And then we see this yellow line here. This is showing me the distance between that plane. We can also see the result again here in millimeters and the XYZ component. Then we have two more measurement types. One is distance between two lines. So let's take from the MPF, and for a couple of seconds let's just make the CSV invisible. Let's take 1, 2 points from here and 1, 2 from here. Now things become a little bit invisible. Probably this is not the best example, so let's just undo the selection. Let's find a better area. 1, 2, 1, 2. So Toolpath now creates two lines out of it and also calculates the distance of it. So let's make, yeah. The last measurement type we have is distance between selected points on trace. This is quite an interesting one. So let's make the CSV invisible. So in case I want to know what is the toolpath length from here to here, you simply click the first point and the second point, because it says select exactly 2 points on the same model, so they have to be on the same model. I click here, I click there, and now we learn this is 5 millimeters. So from here to there, the whole path length is 5 millimeters, 5.08 and so on. Yeah, so let's just try to understand what is the whole path length alongside the MPF. We, let's say, take this point here at the beginning, and then let's say the point here at the end, and we learn it has a path length of 7,000 millimeters. And since it doesn't have any component in XYZ, it's always 0. So much for the measurement pane. Only just one minor information. So you might have recognized you can access, if you have several models in one scene, the measurement tab in every model. What's the difference, or why should you do it? Let me give you an example. So if I'm measuring in my second part, so that's the session 3 CSV, so this is my process data. So if I'm performing measurements now here, let's make an easy one, distance between 2 points. Just try it again. Okay, so we now see here the distance. And this measurement is now bound to the CSV. So that means if I make the CSV model invisible, that means that also the measurement becomes invisible. And if I do the MPF invisible, then I can still see the measurement. So that being said, sometimes it doesn't make a difference whether you execute the measurement on one or the other model, but once you say, okay, for a screenshot I want to hide a model, then it becomes critical, because then it decides whether you can actually still see the result or not. So this is the only moment where you should take this into consideration. Good. Coming to the next tab, which is called selection. So for now, just for a couple of seconds, I would suggest we now take another example. So let's import this mold and die part again. So here we are. It's now imported. And what Toolpath now can help you to do is to find areas where you have a higher density of points. So what you need to type in is, or a cluster of points, let's say. What you have to type in here is a mathematical formula, an expression telling Toolpath what to do. So as an example, if I type in here smaller than 0.05, then Toolpath will find all the points that have a smaller distance to each other than 0.05. So now we see all those areas here that are highlighted in red. Here we have points that are closer to each other than 0.05 millimeters. Why is there such kind of a tool? Well, these are the areas when you do, let's say, let's go even a little bit smaller. Let's see whether there is something. Yeah, okay, Toolpath didn't find anything, maybe too small. These are the areas where sometimes the machine tool also slowed down. And using this tool, it will directly indicate where those areas could be. Or in another use case, let's just import the respective part program into a new scene. Now we have this mold and die part here as an MPF. And now we want to find out, are there any areas where the points are very close to each other. So we go to the selection tab again, type smaller than 0.01. And then we see there are actually points where this is true. It's not easy to detect it, so let's use this I button. And now we see there are points that seem to be so close to each other. They are here on the model, like here as an example. So these are the areas where you might have a look later on your model, whether you had issues during machining there. So this is the selection tool. It also works in the other direction. You can say, okay, please show me everything that is bigger than, let's say, 5 millimeters. Then we see also a lot more, and it totally makes sense because now we see all the points that have a bigger distance to each other than 5 millimeters. Okay. So coming to the next tab, and this is the T tab, standing for tool. And this helps you, and it's only visible in MPF files, to get a better understanding of how the tool travels through your workpiece. Because from the point cloud itself, it's hard to understand that. But if we look at that, like this, we get a better impression what is really going on our workpiece, and we now understand that this workpiece is machined like line by line like this. And we can, as an example, increase the speed. And we can also say, okay, please show the tool only in the selected points. And we see a couple of tools. And if there is no information, so since this is a 3-axis case, there is no orientation of the tool, but for some reason, if we want to change the tool properties, we can do that here. So let's say if we want to increase the diameter, you can do that directly here. And let's get another example where you can use this feature. Let's import our spiral program again. let's just go to the T tab, show tool, and let's play it back. And as I told you, this is actually coming from a robotics use case. And let's just see what happens here at the end. And we see this poor tool is traveling in very quickly changing orientations here at the end. You could really see that. And this will also help you to understand what is going on in the part program and whether this is really what you want to have. And it's obvious that when machining these last circles, the mechanic will definitely run into stability issues, and also the controller will slow down the whole execution. So this T-tab gives you a different impression of the point cloud and what is going on there. Let's go to the Gcode list and expand it. So basically you see here all the Gcode inside the MPF file. It also works with data coming from capture and capture for analysis recorded with Sinemeric Edge. And what we now can do is select segments in the point cloud. Toolpath directly indicates to me which ones have been selected. And if there are multi-selections and I want to understand where is the other selection, I can either scroll through the whole list, or I can say, okay, show selected only, then you will only see the sub-selection. This functionality works in both ways. So if we, let's say, want to find out all the areas where the C component is above 500, let's just type in C500. We now see all the lines here. I select them all by holding down the Shift button. And then we see directly here they are selected in the point cloud. So it works in both directions. If you have process data recorded from Sinemeric Edge with capture or capture for analysis, you can even filter the NC code by the channel. So let's undo the selection. And coming to the last tabs. So here we have a property tabs that simply just tells you some additional meta information, like how many points do we see. And if you have imported data from capture or capture for analysis, there is one additional or two additional tabs. Let's just go through them. First of all, let me just close all the other scenes. And let's open this scene here. We make a very basic mapping now, only the XYZ position, that's enough. So this is process data from capture, and as I said, it allows you also to visualize the NC code, and we directly see this is also a longer program. But what we now also can do is, when we have data from capture and capture for analysis, we can filter by events. So we can say, okay, please filter out all the G0 events. I only want to see the G1 and G2 codes. This you can do here. If we filter out G2, then we end up with even less. And or for some use case, if we only want to see the G0, this you can do here. So quite powerful to directly jump into the area of most interest. And yeah, also here again just some properties. So having said this was now the third webinar, which is all about this menu here on the bottom left, having some very crucial and important features regarding measurement and visualization, and also understand how the point cloud interacts with the Gcode. In the next webinar, you will learn how to visualize time series data and interact also with the time series data with the point cloud. For now, I would say thank you very much for listening. I hope you enjoyed the third webinar. And yeah, hope to see you next time in the fourth webinar. Thanks a lot.